I would like to make a few comments on probability, going back on the issue before, and pointing out one thing, that probability and its meaning is not just something abstract, but it's very much tied to people's belief about society and the mind. So the classical theory of probability emerged in the mid-17th century. That's usually dated at 1654. So the exchange between Pascal and Fermat. And the classical theory was a theory about the human mind, about human rationality. So it meant probability was nothing abstract. That's called mixed mathematics. It was about the subject matter, about human rationality. In Laplace's famous words, he said, probability theory is nothing but common sense put into a calculus. He didn't mean common sense of everyone, but of educated people. And so that's one important observation. And when people witnessed what happened in the French Revolution, the crazy, irrational things, that was the breakdown of the classical theory of probability. You could no longer argue that it would capture the rationality of people if people were so irrational. And that was the moment then in the around 1830, it took a while, when the frequency interpretation came out. So it was about frequencies, no longer about the mind. And before, in the classical theory, so people like Hume and David Hartley, they were thinking that the human mind monitors exactly the frequency of things that happen. How long is everyone talking here? How often is someone nodding to someone else? And that made the unity between frequencies outside and degrees of belief inside. So this was the unit. Around in the 19th century, then, three different interpretations were separated. So the degree of beliefs, or logical probabilities sometimes, frequencies, and propensities. Propensity is the design. A slot machine has a certain probability. So that's the first remark I would like to make. The second one is that the early probabilists were all determinists. And that shaped the belief into that probability is epistemic, because it's the lack of our knowledge. And that you mentioned Einstein, and also to mention Max Planck, this was all this spirit. And when you may remember or have heard that at certain times in the 16th, 17th, 18th, into the 19th century, some countries forbid gambling. And it was not just because people would lose their money, but in a determinist interpretation, if you throw dice, you ask God to decide what number comes up, because it's determined. And the argument was it's frivolous to occupy God all the time with your unrealistic, unimportant business. So the change to this ontic interpretation came, to the best of my knowledge, in the 19th century, and it was two people who had the idea that probability may be outside. And this was Charles Sanders Peirce and Gustav Theodor Fechner. So you may have heard of Peirce, but not so much of Fechner. He was the father of psychophysics. And again, for Fechner's interpretation, it was very important in what he believed. He believed in monism, Monism is the idea that the mind and the world are just two sides of the same coin. And since he knew that people have, or believed people have free will, so he inferred nature must have free will too. And that was the beginning of this interpretation that probability is actually in nature. I just make the point that may sound funny, but the point is these interpretations come often out of key convictions that people have. And later, then the topic was that opened up the possibility of the Copenhagen interpretation of quantum theories. So Max Planck, who is often said to have invented quantum theory, was totally unhappy about his discovery. He was a man who was looking for order, certainty. He was a very reliable man, and his teacher told him that if you study physics, everything is already known, nothing to be discovered. But Planck seemed to like that. And then the thing happened that he didn't want. He discovered something, and the thing he discovered didn't look like determinism. So, final remark. The statistical mechanics is also inspired by human behavior, by theories of human behavior. And the short story is, there is a Belgian astronomer, Adolphe Quetelet, who used normal distributions as a model of human observational error around the true position of a star. And Quetelet was interested in human behavior, such as suicide, murder, and other typical human activities. And he could not predict who is committing, say, a murder or some crime, but he observed that the proportion of crimes being committed is different in London than in Paris, and they're stable, the differences are stable. So he concluded, maybe it's like in astronomy, the human error, so that we need to build he was one of the founders of sociology, a sociology that does not look at the individual, but at the collective. And the collective are the same, normal distributions. So that's the first part of the story. Now, Maxwell and Boltzmann were pondering about the behavior of molecules. And they also found them highly unpredictable. And both of them had read Quetelet. And to make it short, and I thought maybe molecules are like humans. Unpredictable, but predictable as a collective. An outcome, statistical mechanics. The revolution in physics, from a deterministic to a probabilistic one. So these are just some ideas to give you a perspective that much of what we are talking of is probability, ontic or epistemic, comes out from human beliefs, human conceptions. And we are still, when we listen here to the intensity of the arguments, we are still in this. And I must say, I enjoy this meeting very much. And last, a remark on medicine. So if you would live in the 19th century, there were three kinds of philosophies about what a doctor is. One is an artist, a person who knows better than you and everything. But there's still some artists around. And the two major other competitors were the determinists, so going back to Laplace. They were looking for causes. And the statisticians, they're looking for chances. And there was a fierce competition between the two. So Claude Bernard one of famous physiologists in the 19th century, and also the person who invented blinding in experiments, accused his statistician colleagues of not understanding or not even wanting to understand the causes, because they're not looking for causes, just for chances. And it was actually Sir Ronald Fisher who got these fighting groups into one by making statistics and experimentation the same thing, dominated by statistics. But it's a short history to throw in and to see how much what we are debating in physics or even in philosophy depends on human nature.
Some people were asking, how do we tie all this discussion of physics and everything back to broken science? The fact that there's speculation and various theories being tried out and all that kind of thing, that's in no way broken science. That's all to the good, absolutely to the good. But the desire to have one's theory be true can sometimes be overwhelming for some scientists. And so some scientists want to change the criterion of what makes a good model. So we say what makes a good model, a good theory, is at least its predictive usefulness, at the very least. The best theory would be one where every one of its premises are true, and what it says about the thing being predicted says with certainty, and it's always accurate. That's the absolute best theory that you could possibly have, and that's also a predictive theory. But particularly like the many worlds interpretation of quantum mechanics, there are some people who want to say, well, you know, I love this theory so much, I want to change the criterion of a good theory to being that which makes a good explanation. My theory explains the data or the thing I want explained very well, therefore it's a good theory. But the problem is, of course, for any given observation you have or any given idea you have, you can come up with innumerable explanations. Each one would be just as valid if they explained what you wanted to explain at least as well. So that's not a very good criterion to use, but they're trying to sneak that in order to avoid the idea that in order for the theory to be able to check it, that you should be able to make good predictions with it. So you can't make a prediction with the multi-worlds. With some ideas of the multiverse, perhaps you can, different kinds of multiverses, but with the many worlds one, you can't make a prediction that can never be tested, and so they want to eliminate the idea of testing and making predictions, part of science, and just turning it into explanation. If you allow that to happen, well, you open the door for everything, and what we've seen in, I don't want to make this at all political and everything, but we've seen in various other aspects of the scientific life where the theory, because of itself, is more important. Therefore, we don't need to check our predictions. We see this in climate change and so forth. The seriousness of the charges were heard. That becomes the justification for the theory more than anything else. And that brings us right back to philosophy and ideas like the precautionary principle and all these kinds of things, and whether that has any validity, I don't think it does. But we can discuss all those kinds of things. So, but it's not that all this stuff about what's going on in physics is in any way wrong or broken or anything like that. That's not the case. But when they try to change the criterion of what we mean by a good theory, or what theories should be and what consequences of theories are, and when it ventures off into that, into what's the best thing to do, all of that, it becomes broken. And that's what we have to sort of keep an eye out for. Maybe we should ask questions too. I don't know if anybody else has any questions. I feel like I'm hogging the time.
Cue the many worlds interpretation of quantum mechanics. There are several things which make it terminally ill, but I'll give you the one which absolutely downs it. What goes on is that if you are making a measurement of a physical system in quantum mechanics, then all quantum mechanics can tell you is the probabilities of the differing possible outcomes. And the many worlds interpretation says that each one of those, when you make the measurement, each one of those is realized in a different universe, and the universe actually splits off, and they're always inaccessible to each other. Slightly different multiverse from the cosmological one that Peter was talking about. The knockdown of the many worlds interpretation is that you can, if you like, treat the measuring apparatus and the thing that you're measuring as a single quantum system and just study the interactions within it, which you might say comprise the measurement, study them from the quantum mechanical point of view. It's the same interaction, and if you do that, you do not get any splitting. And you cannot have the universe splitting and not splitting at the same time. So that is the contradiction. That's the most deep reason why the many worlds interpretation is nonsense. Now, about that Solway conference, essentially what came out and what Peter summarized in the words of David Mermin as shut up and calculate, became known as the Copenhagen interpretation. And I fully agree with Peter that in the 1920s, it was the only viable way to proceed because people really didn't understand what was going on at a deeper level. I would say that responses to it, such as the many worlds interpretation, are not just useless, they're actually worse than useless, far worse, because they provide a rationalization for why you might never be able to go further. I think you should do your utmost to go further. Who wants the mic?
Yeah, questions?
Not a question, but a response to what you said, Matt. I'm a lawyer, not a physicist. I've dabbled in this, and to the extent that I've been around Greg, it's gotten to me through osmosis. But I think there's an important thing. I'll relate it to what I do, and it goes specifically to what Matt's talking about. When you're trying to prove something in court, and I was a defense attorney as well as a prosecutor, but it reminds me of this notion there's an infinite number of ways to be wrong. And that's the problem with, it seems to me, the frequentist approach, which is to say, in court, a series of events happened already. There's an event, there's a dead body. And the most likely interpretation is, frequently, my client did it. And so the government proceeds, they've got to establish by a certain quantum of evidence that, in fact, your guy is the guilty party. And what defense attorneys do, what you learn to do, at least I think the good ones and the ones that I learned from, was you take that set of data and you really kind of construct, it's a frequentist approach, which is, let's suppose for a moment, horror, my guy actually did it. Let's suppose he is the guilty bastard and I know it. My job is to construct from the data that I have, that I know the government's got, that they've turned over in discovery, I know all their witnesses. What I'm going to do is construct an alternative hypothesis that is consistent with the evidence and will yield a result that is, my guy walks out of court at the end of the day. And so I think that having gone through that process over and over again with different sets of facts, you come to realize that it seems to me that the frequentists are patting themselves on the back when all they're doing is constructing an infinite number of possible stories about why this isn't what you think it is. And I think that's really what's going on with the frequentist approach, is that you've produced one of the many innumerable cases of it's correlated, it's consistent with, to use what Matt talked about, consistent with the data, but in fact you could be wildly wrong, and you could be confirming an obviously not correct theory. And it goes on all over the place. It's just a way of thinking about the world. So, for whatever that's worth.
Do you have anything that you might say about how to combine quantitative DNA evidence and likelihoods with qualitative prior information about a case?
Yes, but not that I'm prepared to do right now. Yes.
If the glove doesn't fit.
Right. If the glove doesn't fit, you must acquit.
So can I just make a couple of comments about
This is something that I've often thought about probability in the courtroom, forensic science, and so on. And of course, Laplace's great essay on probability went into that role of probability in jurisprudence. One of the things that's different from science, you know, as I was talking about cosmology, because that's my field, but it's a process. And I talked about how often when you publish a paper, it sort of implies a closure to that process, which is not real. It's kind of artificial. And we just carry on getting hopefully closer and closer to a complete knowledge, but maybe never getting a complete knowledge. And we're all quite happy that our hypothesis is a working hypothesis. It might be a good one or it might be a bad one, but that's the way we do it. And we don't have the constraint that you have in a court of law, where you have to end at some point, and your defendant is either guilty or not guilty. It's forced into that binary choice. And one of the issues that I've always had as a Bayesian, I was converted to Bayesianism quite a long time ago. Actually, it's worth mentioning that almost everybody who works in my field now uses Bayesian techniques, for the reasons that I tried to elucidate before. And that's not true throughout physics, but it's true in cosmology. One of the problems I have is that you know, in a Bayesian approach, you have model comparison techniques. Your data may favor one model over another, and it may get more probable when you make a measurement or you reveal more data. It might favor one model over the other. But it's very difficult to get absolute certainty at the end of that process, because it's a never-ending thing. You might get to a very high probability of your model and a very low probability of the alternative model. And then you ask yourself, what does reasonable doubt actually mean? Is it ever unreasonable to doubt? And I have a big problem with that. So if I were ever selected for a jury and instructed by the judge to say, you know, you have to decide the weight of evidence has to be beyond all reasonable doubt, I would ask, what do you actually mean by that? And I don't know, because I think I have doubts in lots of things which are reasonable. And surely it's reasonable to live with uncertainty rather than forcing yourself to believe or not believe. And so you'll never close a court case if you have that attitude. Yeah. So I'd be excluded from a jury probably if I ever.
Definition. Yeah, there's a great definition for what constitutes a reasonable doubt. The jury instruction, the standard bench book instruction for what constitutes a reasonable doubt, it's neither fanciful nor speculative. And it's suggested by the evidence or lack of. And it's one that leaves you in your mind with and that's where they get to that I'm not willing to throw a guy in jail. I'm almost sure. But it's a doubt that's neither fanciful nor speculative. It's a great definition. I'll send you a copy. You'll love it.
I want to speak to this because I've tried about 150 criminal cases as a prosecutor and about 100 as a defense attorney. And when I was a prosecutor, I felt like the biggest obstacle to winning the case was the burden of proof. And so I developed several lines of argument to make that mountain smaller and smaller and smaller. And then when I switched sides to the defense, my working hypothesis was that there's only one defense, and that's reasonable doubt, and there's a multitude of ways to create it. Alibi, justification.
Saudi, some other dude did it.
What else? And so developed a whole line of arguments based on reasonable doubt is higher than Mount Everest. Sometimes I think it devolves around to this little joke that a jury, at least in America, of 12 people who are selected, chosen, and sworn to decide who has the best lawyer.
I think that there are different standards of proof required in civil and criminal cases, and the one thing that guidebook for lawyers that you cited cannot do is give numbers. It cannot say 1% doubt in criminal cases, but 10% in civil cases. They can't go numerical. You can see people in the history of probability, in the history of jurism, wrestling with the underlying quantitative notion without ever mentioning numbers.
Well, it's funny you bring that up, because to return to p-values, to bring it back to what we're talking about, how bad, how awful, how much injustice would there be if we said, well, reasonable doubt really means p equals 0.05. You know, I mean, how atrocious the outcomes would be if we use that kind of mathematical, you know, pseudo certainty.
And your jury pool is people that have nothing to do.
Right, we're getting paid $10 a day to be there. You know, the other joke is that a jury is made up of the 12 people who weren't smart enough to get out of jury duty. So.
I mean, the other thing is that expert witnesses often present evidence in
Yes,
the form
as
of
if.
p-values,
Yes.
and they're often very misleading, and we know of many miscarriages of justice which are caused by, essentially, expert witnesses who talked a load of statistical nonsense.
If you want to give yourself a horrible thought, is look at all of the pieces of scientific evidence that have turned out to be complete nonsense. And particularly, I can think of several of them, but one of them was bite marks. The idea that, you know, bite marks was a science, and that some guy could come in and go, oh yeah, well, the bite mark on that body is that guy's. You know, that's that guy's jaw or teeth or whatever. You know, there's a lot of, even what we accept in popular conceptions of these things, DNA evidence. I was dating a gal here in the Valley, actually, was an associate professor at ASU Law School, one of the top 25 law schools in the country. And she was also the general counsel for a genomics company, and she did genetic testing, and this is 15 years ago, and she was saying at the time, the prevailing theory about genetic evidence, there's this whole bunch of stuff that we don't know what it means in your DNA. And she used to say they call it like artifacts, so that it doesn't matter, and she used to laugh, and she'd say, 10 years from now, this will be looked at as the dark ages of, you know, genetic technology, and yet we were using it to convict people, send people to jail forever, on sort of chained probabilistic reasoning. Well, why is your DNA in that location, you know? And so it's a lot of science can be used to produce massive overcertainty.
Katie just showed it to me earlier today. This came on yesterday. Colorado Bureau of Investigation finds DNA scientists manipulated data in hundreds of cases over decades.
Yeah, the one for me in the military was the mandatory drug testing. The mandatory drug testing probably convicted more people, because as they go back, you know, here's your client who's like, I've never done a drug in my life. You know, in the military, you're subject to random urinalysis, which is a fairly, you know, known science. We've got this down. We understand how this works. We pull the urine. We've got this metabolite for a drug, and it shows up in your urine. And then the conclusion from that is there's this sort of logical leap, and the law struggled with this, which is, okay, it's in my urine, but now you have to prove that the actual crime is willful use of that substance. That's what makes it wrongful. So you get the innocent ingestion defense. But the other problem is that what happens when the guy says, I've never taken that in my life. I've never stuck that in my body. And then what about all the alternative ways in which things can be metabolized? And people were convicted. There's a whole litany of cases over this, but and it later comes out, oh my God, what do you know? The Navy drug screening lab, the chemists were using the drugs themselves, and there's no, I mean, you know, so there's all these problems that exist, and yet you would have innocent guys sitting in court. You're sitting next to him. He's like, I never did this, or I swear to you, I did not smoke pot. But you're sitting in front of the jury, and they're going, oh, right, how did that get there? You know, and then of course there's the lost second sample. I mean, it's rife with the possibility of innocent people going to prison, and it certainly has happened, for sure.
And there is a reason for all of this mess. The law school don't teach statistical thinking. I once taught a course at the University of Virginia Law School. I think it was the first one, and maybe the last one. And the studies show that most lawyers, most judges, including federal judges I've trained, have no understanding of probability. And as a consequence, you can mislead them on top of what you said. For instance, when I trained federal judges in the US, I give them very simple task. Now, DNA evidence. The problem is not just that DNA evidence is difficult, but that people don't learn to understand. So let me do a test with you. So you are accused of having committed a murder. There's no evidence against you except one thing. Your DNA matches with the traces on the victim. So you stand trial, and the judge asks an expert witness. And the expert witness may say, because they've never trained in risk communication, may say, Your Honor, the probability that this match occurred by chance is 1 in 100,000. Okay, looks not good for you. So what we do, we train the judges not to allow this statement. That's a single event statement, and people are confused about it. So the probability to you. So rather, the expert witness should say, Your Honor, out of every 100,000 people, one will show a match. And then you think, in this city, there are 3 million. Oh, it's 1 to 30. It doesn't look so. So these are very simple tools of risk communication. And we brought it first into the O.J. Simpson trial, and where the judge asked the expert witness to testify in frequencies, not in single event probabilities. And the expert witness was a statistician, said, it's the same anyhow, and didn't understand that the risk communication matters. And that could be easily trained, but it isn't. Same problem in medicine. Most doctors are innumerate. Ask your own doctor what specificity means, or sensitivity means. Good luck, you may have one of the 10% or so who sees through, but most doctors cannot read an article in their own field because it's all randomized trials, statistics, and they don't know what exactly an odds ratio is or cannot evaluate the thing. And this is a state of healthcare in which we are. So doctors go by rumor, what they've heard, or where they earn money. And patients are often in the same state. They don't take the effort to educate themselves. And then there are in this country now an estimate of 250,000 people who every year die in hospital from preventable. Yeah, that's it.
Patrick, did you want to go there?
I had a question about that. It seems like this. It seems like where your average person, where the rubber hits the road for the average person in all this is maybe medicine and technology, like in the average life. And I guess it's a pedagogical question. We're pointing out all the enormous damage or risk that comes from the practice of broken science in society. And yet I've heard a few handy framing techniques that really would help, that are easy to understand. I don't remember the Australian term, but you know, for guys like me, easy to understand. And in the readings before, I think you had coined the term a fast and frugal heuristic. It's like in the military, you're always making decisions that matter, that might affect your health in a major way, with radically limited information, but you have to be able to make the decision quickly, and I think we all find ourselves in that situation with respect especially to healthcare and contemporary society. And I'm wondering what's a suggestion for, you know, as Greg said, you're not going to save the world. You're not going to come in on a white. There's no Messiah complex and all this. But is there a way to to train a fast and frugal heuristic so that normal folks are less vulnerable to the predations of broken science?
Yes. So what is a fast and frugal heuristic in the first place? So a heuristic is useful in a situation where probability theory doesn't give you the right answer. So in situations of uncertainty, so for instance, whom to marry, If you sit down and calculate, good luck. Or where to invest. So, and what part of my research is, we design heuristic strategies for decision making. I'll give you one example. We worked with the German military when they were in Afghanistan. A problem is there are checkpoints and cars come in and too many people are being killed in the cars because the soldiers think they are enemies. How to do that? NATO has no instruction except first shoot in the air and then in the tires and then at the person. But when? And a fast and frugal heuristic is a device that helps them to make a decision fast in this situation. And it asks only 3 questions. First, is there one person or more in the car? If there are more, fine. If there are one, that could be a terrorist, but not sure. Then the next question is, does the person speed down when the signal is? If not, alarm, and should. Otherwise, a last question is there a notice around about a certain car that may be problematic, like a red Honda? So this is a fast and frugal heuristic that can be executed very fastly, systematically being trained, and it reduces the number of people, the false positive, being shot by more than a half. So that's an example. The same thing you can train in healthcare. So we have worked with US hospitals. So a man comes into hospital with severe with severe chest pains, and the question is, should one send him into a coronary care unit or in a regular bed with telemetry? And that needs to be decided soon, as otherwise it could be too late. And there's similar type of decision trios that help them to quickly make decisions, and that reduces the usual chaos that you have often in these units. And so heuristics can be very useful in situations where you have no time and you have also not the possibility to calculate the right answer, and because there's too much uncertainty. And the systematic study of heuristics is still not be taught. And that's another case. And there are entire parts of science, particularly at the moment dominant part of behavioral economics, who thinks of heuristics as something generally bad, and believe that logic always gives you the right answer. And there have been 2 Nobel Prizes for that. And we try to bring uncertainty back. There are, at least in human life, there's uncertainty. You never know what the other person is going to do. You have to trust. And imitation, trust are all heuristics that we use to get along with one another.
Malcolm, will your thoughts survive lunch?
Well, it's just going to be a very quick, just a bit of information really, because talking about the cases where they got the statistics wrong was actually a Professor Roy Meadows, where a child, 2 children died of cot death, and the odds of cot death are 1 in 18,000 or whatever. And because 2 died, Professor Meadows said it's 18,000 times 18,000, which is 175 million squillion. And on the basis of that very large figure, the mother was sent to jail. And so basically that was just to provide that little bit of detail as to when that went horribly wrong. So that was how that went.